Welcome to our channel. Today, we're diving into the fascinating world of AI and machine learning. We're talking smarter devices, personalized experiences, breakthroughs in healthcare, even the way we create art. So we're going to break down the top techniques that are shaping the future of technology. Whether you're a tech enthusiast, a student, or just curious about what's on the horizon, this video is your guide to understanding the building blocks of AI. We're going to keep things clear, concise, and hopefully pretty fun. So let's jump right into it. All right, so first things first, what exactly are we talking about when we say AI and machine learning? Well, in the simplest terms, artificial intelligence is the big umbrella. It's the concept of creating machines that can perform tasks that typically require human intelligence. Think of things like problem solving, decision making, even understanding language. And this is where machine learning comes in. It's a subset of AI that focuses on giving machines the ability to learn from data without being explicitly programmed. Instead of hard coding every single rule, we feed these algorithms massive datasets, and they figure out the patterns and relationships on their own. Machine learning is all about that learning by doing approach, but on a much larger and more complex scale. Now, this data can be anything: text, images, numbers, you name it. This could be anything from recognizing faces in photos to predicting what you'll buy next on Amazon. So, as you can imagine, this has some pretty huge implications. One of the most common types of machine learning is supervised learning. Think of it like training a dog with treats. You give it a command, and if it does the right thing, you reward it with a treat. In supervised learning, we're essentially doing the same thing, but with data. We provide the algorithm with a labeled data set, meaning we give it both the input and the desired output. So, for example, if we're teaching an algorithm to recognize cats in pictures, we'd show it thousands of images labeled as cat or not a cat. The algorithm then uses this labeled data to learn the patterns and features that distinguish cats from other things. And once it's learned these patterns, it can then analyze new, unseen images and tell us with a certain degree of confidence whether or not they contain a cat. It's all about learning from examples to make predictions about new data. Now, let's talk about unsupervised learning. This one's a bit different because, in this case, we don't have labeled data. Instead of giving it explicit instructions, we let the algorithm explore the data on its own and discover any hidden patterns or structures. One common example of unsupervised learning is clustering. The algorithm's goal here is to group similar data points together based on shared characteristics. Think of it like automatically sorting your socks by color, even though you never told the machine what the different colors are. This is super useful for things like customer segmentation, where you might want to group customers with similar buying habits together for targeted marketing campaigns. Another key application is anomaly detection. Since the algorithm learns the normal patterns in the data, it can easily flag anything that deviates significantly from the norm. So, while supervised learning is all about making predictions based on labeled data, unsupervised learning is more about discovering insights and patterns that we might not have even known to look for. Next up, we have reinforcement learning, which is inspired by how humans and animals learn through trial and error. Imagine you're teaching a dog a new trick. You reward it when it does something right, and you might scold it or withhold the reward when it messes up. Reinforcement learning works in a similar way. We have an agent that interacts with an environment. The agent takes actions, and for each action it receives feedback from the environment in the form of rewards or penalties. The agent's goal is to learn the best sequence of actions that will maximize its rewards over time. It's like playing a video game where you don't know the rules. This type of learning is being used to train AI systems for incredibly complex tasks, like playing games at a superhuman level, controlling robots in dynamic environments, even optimizing traffic flow in cities. This type of learning has the potential to revolutionize fields like robotics, automation, and even personalized medicine, where AI systems can learn to make optimal decisions in real time. Now let's talk about the engine that powers a lot of these machine learning techniques. Neural networks. These are computational models inspired by the structure of the human brain. Just like our brains have billions of interconnected neurons, neural networks have interconnected nodes, or artificial neurons, that process and transmit information. Each connection between these nodes has a weight assigned to it, which determines the strength of the connection. During the learning process, these weights are adjusted based on the input data, allowing the network to learn complex patterns and relationships. Neural networks come in different shapes and sizes, but they all share this basic structure of interconnected nodes and adjustable weights. They're particularly well suited for tasks like image recognition, natural language processing, and even predicting stock prices. And as we feed them more data and increase their complexity, they become capable of even more sophisticated tasks. Deep learning is essentially what happens when we take these neural networks and crank them up to 11. We're talking about networks with many layers of interconnected nodes, hence the term deep. These deep neural networks can learn incredibly complex patterns and representations from massive data sets. Deep learning has been the driving force behind many of the recent breakthroughs in AI, like self-driving cars, advanced image recognition, and even realistic language generation. It's what allows AI systems to understand and respond to the world with a level of nuance and sophistication that was previously unimaginable. And as we continue to develop more powerful hardware and algorithms, deep learning will only continue to push the boundaries of what's possible with AI. One of the most exciting areas of AI is natural language processing, or NLP. This is all about teaching machines to understand and interact with human language. It's a huge field with applications like chatbots, machine translation, sentiment analysis, and so much more. Think about all the ways we use language every day: texting, emailing, searching the web, talking to our voice assistants. NLP is what makes it possible for machines to understand and respond to us in a way that feels natural and intuitive. One of the key challenges in NLP is the ambiguity and complexity of human language. But despite these challenges, NLP has made incredible strides in recent years, thanks in large part to, you guessed it, deep learning. Another fascinating area of AI is computer vision, which focuses on enabling machines to see and interpret images and videos. This involves tasks like object detection, image classification, and even generating realistic images from scratch. Computer vision aims to give machines similar capabilities, allowing them to extract meaning and insights from visual data. This has huge implications for a wide range of industries, from self-driving cars that need to understand their surroundings to healthcare systems that can analyze medical images for signs of disease. And just like with NLP, deep learning has been a game changer for computer vision. By training deep neural networks on massive datasets of images and videos, we've been able to achieve incredible breakthroughs in accuracy and performance. Now let's talk about generative adversarial networks, or GANs, which are a fascinating type of AI model that can create new content, like images, music, and even text. Imagine having an AI system that could paint a masterpiece, compose a symphony, or write a screenplay. GANs work by pitting two neural networks against each other in a kind of AI arms race. You have a generator network that tries to create realistic-looking data, and a discriminator network that tries to distinguish between real data and the fake data generated by the generator. As these two networks battle it out, they both get better and better at their respective tasks. The generator becomes more adept at creating realistic-looking fakes, while the discriminator becomes more skilled at spotting the subtle differences between real and fake data. This adversarial process pushes both networks to their limits, resulting in the generation of incredibly realistic and creative content. GANs have been used to create everything from photorealistic images of people and objects that don't exist to stunning works of art and even realistic-sounding music. It's a rapidly evolving field with the potential to revolutionize the way we create and consume content. Finally, let's talk about transfer learning, which is a powerful technique that allows us to leverage the knowledge gained from one task to improve performance on another related task. Think of it like this. Let's say you've trained a deep neural network to recognize different breeds of dogs. Now, you want to train a new network to recognize different types of cats. Instead of starting from scratch, you can use the knowledge that the dog recognizing network has already learned about animal features, shapes, and patterns. This is especially useful when you have limited data for the new task, as you can benefit from the vast amounts of data that the pre-trained network was trained on. Transfer learning is used in a wide range of applications, from natural language processing to computer vision and beyond. It's a powerful technique that allows us to build on existing knowledge and create more sophisticated AI systems more efficiently. So there you have it. We've covered some of the most important techniques shaping the future of AI and machine learning. From supervised learning and neural networks to natural language processing and generative adversarial networks, these techniques are powering a new wave of innovation and transforming the way we live, work, and interact with the world around us. Thanks for watching. If you enjoyed this video, make sure to like, comment, and subscribe for more tech content. Let us know in the comments which AI technique you found most interesting. We're always looking for new topics to explore, so drop your suggestions below. Until next time.